Okay, I'm going to do a short video on how to use GAMs. It's short because with all the other work we've done, it's really pretty easy, I think. First, need to make sure that we're including the mgcv library for this lab. So up at the top, we need to do library, and then go to Tools, Install Packages, add mgcv, and install it. You may already have it installed, that's okay. You also need to include it here, that way it's loaded in each time into your script. I'm going to go ahead and grab this function, and what this function does is create polynomials up to 4 degrees. Pretty complicated, but that's what we need for R. Okay. And I should mention, sometimes you get these messages in red. Red really should just be for errors, but in this case, this is just a note saying that it needs to go ahead and load that library. I don't know why it's in red. Okay, so let's go ahead and play with our polynomial. I'm actually going to grab all this code, but we'll just play with the first couple lines to get started. Okay, and please go ahead and do this. So if we call our poly2d function, you'll see we get a polynomial with some random noise in here. And we can see the polynomial better if we take out the noise. So this first parameter is the number of entries that we're getting, so 0 to 100 for the independent variable. And then the standard deviation of the noise that we're injecting into it. There is no mean. We usually don't change the mean, really. Okay, so we can just get increasing amounts of noise until our signal disappears completely. Okay, so I'm going to leave it around 10 so we can see the signal. There we go. And then these other parameters are going to change the parameters for the polynomial. So here's B0, the intercept, the slope, the second order, third order, and fourth order values within the polynomial. In other words, this is x times B0 or B1, b2 times x squared, b3 times x cubed, b4 times x to the fourth. So as you go increase, these contribute much more because they're multiplied times x raised to larger and larger values, which is why you see these go down in size. So if we change the intercept, we can see that our intercept goes up here. If we change the slope, we can see that the slope changes. Okay, but it also tends to affect the rest of the curve, and the reason for that is because this initial slope is then setting how these other parameters will impact the rest of the curve, and these are pretty touchy, so you can spend quite a bit of time playing with it, but I've set these up so that they make a nice polynomial with minimum and a maximum that go back up and back down again, something that we just couldn't model with linear or with a GLM. We can do it with a GAM. So if I run a GAM and plot it, boom, there's our GAM. As I said, pretty easy to do. We just go ahead and use the same notation we had for GLMs. So the function is GAM, and then we're doing our measures. This is our y equals, but with a tilde. Whoops. And then notice that here's our spline function wrapping our predictor or covariate or independent variable. And then the data, and then there's our gamma to change the amount of smoothing that's allowed. So if we change the gamma, we really don't see a lot here. Let's change it a lot. There we go, it smooths it out. Obviously far more than we actually want it to. So with this data set, you know, it's pretty easy to match this, and 1.4 is fine. Okay, and then if we run a summary, we're going to get a bunch of information here, including our statistics, significance codes. These are our actual coefficients, but difficult to interpret, so don't worry too much about them. You will see down here that you've got your R squared, deviance explained. Now, one of the things that you'll see is missing is AIC. So to get AIC, it's not in the regular summary. We've got to run another function, and there's our AIC of the model, given that data set. All right, and that's it.